Purchases 13 decks of cards. He randomly draws 52 cards from the deck and counts how many of each suit, clubs, diamonds, hearts, spades, there are. In total, there were 676 cards randomly drawn. According to the deck of cards, the card type should be evenly distributed, with 25% of each suit being selected in the deck. The results of the 13 deck of cards were right there. And A asks is to find the expected frequency and the degree of freedom. So what you would do, just look right here, what you would do for A, to find the expected frequency is take the number of childs, which was 676, times the probability, which was 25%, which in decimal form would be 2.25, which would equal 169. And you just do that in your calculator real quick. And 169, meaning that that's the expected frequency for all the 4 types of cards. So there'll be club, diamond, hearts, and spades. So 169, 169, 169, 169. That's the first part. And the second part would be to find the degree of freedom, which is easier, which you would do. The formula is V equals, so V would be the degree of freedom equals N minus 1. So number of rows and number of columns minus 1. Since we got number of columns, number of rows, I think, which would be 4. So you do 4 minus 1, and the V would equal, so the degree of freedom would be 3. And then for B, what you would need to do is grab your calculator, and then you would go to hit stat, and you go to edit, and then you would type in the observed frequency here, and then the expected frequency, which was 169. So you would type 169 for all of them, and then you would hit stat, you would go to test, and then you would go all the way down to D, I think. Yeah, D. And then you don't change any of that because you already found the observed, and you put the expected in the edit. And then the degree of freedom, which would be 3, so you need to change that to 3. And then hit calculate. And then you would get your p-value, which is 2.47 rounded to 3 sig figs times 10 to the negative 7th, which you would write. Which would be less than 0.1 or 10%. And then next you need to state your hypothesis, which would be HO, which is the null, and the alternate. And the null would be it follows uniform distribution. UD is uniform distribution. And alternate will be it does not follow that. And then from what you got there, which was the p-value you calculated, it was less than 0.1, meaning that it is sufficient. Because remember, if it's higher or low, reject the whole. And this is low, so which you would reject the whole, which is the null. So you would put sufficient evidence to reject the null. Therefore, you gotta add therefore because you're trying to state the conclusion. So therefore, it does not follow uniform distribution. And that's basically how you do chi-squared goodness of fit test for independence and independence or uniform distribution.